In this video, I would like to show with practical examples how SSH port forwarding or SSH tunneling works. We are going to take a look at three types of SSH tunneling. The local or forward tunneling, in other words, the remote or reverse tunnel, and the dynamic tunnel. Let's start with SSH local tunneling. In this example, our client is going to be this Kali host, which you can see on the screen, and the server is going to be a Raspberry Pi, which has an IP address of 192.168.1.97. So let's SSH into our server first. To enable local tunneling, there is one option that needs to be allowed on the server configuration file, and that is called allow TCP forwarding. You can see that both options are commented out here, but the default option is yes. So we don't have to modify the server configuration in this case. I am going to demonstrate the local tunneling with a simple Apache web server which runs on the Pi and listens on TCP port 80. As you can see from the output of the ss command. So I have created a simple HTML page for testing purposes, so we can normally access it with the client. Now, let's imagine that a firewall blocks access to TCP port 80, so the client can't reach the web server, but we still have SSH access. In this example, our firewall is going to be a host-based firewall on the Pi, but of course it can be located anywhere between the client and the server. So I am going to create a simple firewall rule which will deny access to our web server. So this rule is denying access to TCP port 80 from any host, and with the reject target we are sending back on ICMP to inform the Kali host. So as expected, we don't have access to the web server anymore, but we still have SSH access to the server, and the local forwarding is enabled. So in this case, SSH local tunneling can be useful for us. We can have access to the website with the following command. I'm going to type the command first and explain it afterwards. So, what does this expression mean? It means that we can access the web server on port 8080 on the local machine. So it seems like the web server is running on the Kali host, but it is not. We are accessing the same web server on the Raspberry Pi through the SSH tunnel. So as long as this SSH session is open, we have access to the site. The best way to understand this command is to observe it in two blocks or two pieces. The first part is pertaining to our local machine, the client, and the second part is related to the server. This means that we want to access port 80 on the server, and we want to map this port to port 8080 on the client side. I know that it is a bit confusing because of the two local hosts, but these mean different computers. The first one is the client, the Kali host, and the second one is the server, the Pi. The way I remember this command is that the second part, which is separated by the colon, is always associated with the server. So we want to have access to TCP port 80 on the server, and the first part specifies the port which we are going to use on the client. In this case, port 8080, but it can be anything else. It's our choice. The first local host, which means the client, as I said before, can be omitted, so left out. The command still works the same way as before. And of course, the second local host does not have to be the Pi, so we can put any IP address here which the server can access, and we cannot because of a firewall rule denying access for us, for example. So, for example, let's access my Grafana server through this Raspberry Pi. It has an IP address of 192.168.1.98, and the service which we want to have access is listening on TCP port 3000. And let's access this service on TCP port 4000, for example. So it works the same way, just remember that we can access other hosts as well. The service does not to have run on the same host which we are SSHing into. I would like to mention two useful switches which can be useful with tunneling, the -N and the -F switch. So normally we are presented with a login shell after entering this command, but we don't necessarily want that. So the -N switch prevents us from having an interactive login shell, and the -F switch puts this whole thing in the background. So the SSH tunnel has been established as before, but it is in the background, as we can see. So eventually we can send this process a SIGTER signal and close the tunnel eventually. So local tunneling allows us access to services and ports which are inaccessible for us because of firewall rules. It's also worth mentioning that everything is going to be encrypted through the SSH tunnel, so we can access unencrypted services safely. So now let's move on to remote SSH forwarding. Remote tunneling is going to be useful for us in a different situation. I am going to highlight this with a similar example. We keep the web server on the Raspberry Pi, which we have used before. And now we want to access this server from the internet. So, for example, I want to show the website I have created to my friend or to my colleague. But my site cannot be accessed from the internet, of course, because of several reasons. It is behind the net, it has a private IP address, and port forwarding is not enabled on my firewall. But in this example, we have a server which is accessible from the internet, and we have SSH access to it. So let's SSH into it first. To use remote forwarding, another option needs to be enabled on the server, and this option is called gateway ports. So this option is disabled by default, so we have to enable it. So let's change this setting to yes. And now we need to restart the SSH daemon and make sure it is running properly and we didn't make any mistake in the configuration. It seems like it is. So let's test remote forwarding. We need to issue the command from the host which we want to access from the internet. So in this case, the Raspberry Pi. I am going to issue the command first from the Pi and explain it later. It is similar what we have seen before in the previous example, but it is different in a couple of things. First, we use the -r switch, designating that we want to use remote tunneling. The last part of this expression means the local server, the Raspberry Pi in this case. So it means that we want to access the service which runs on the Raspberry Pi on TCP port 80, and we want to access this port on the remote server with this public IP address on TCP port 8888. Again, of course, it's our choice. This can be anything. So after this SSH tunnel has been established, we can access the web server through the public server on port 8888. But it is not working just yet. The firewall prevents us from accessing this port. So let's take a look at the firewall configuration. We are using firewall D here. And the default configuration is kind of restrictive. So I'm going to add this port to the firewall configuration. Looks like this port is open now on the server side. So let's check it again. It is working just as it should be. So as long this SSH remote tunnel is up, which we have initiated from the Raspberry host, so as long as this tunnel is up, we have access to this site from the internet. I believe that this server runs in a Swedish data center, so I am accessing the web server on the Raspberry Pi, which is right next to me on the desk, through Sweden, which is kind of interesting. So remote tunneling can be useful for us in a situation where an internal server which we want to access is behind a firewall or net, or doesn't have a public address. So if we set up this tunnel from the internal host, which in this case is the Raspberry Pi, we can access the given port from the remote server. So now let's move on to the final topic, which is dynamic forwarding. In this example, we are going to use the same remote server as in the previous case. And this example, we are going to set up a SOX proxy with the help of the remote server. The -d flag indicates that we are using dynamic forwarding, and the number following the -d flag specifies the port which we are using here for the proxy server. So let's test it. We need to redirect our traffic to the proxy server and tell our browser to use it to forward the traffic. We are using Firefox here, but the proxy settings can be different for other browsers. But here we need to select the SOX settings and type in localhost and the port number, which we have specified here before. So now, if we visit a website, for example, whoer.net, to check our public IP address, the website sees the IP address of the remote host, which is located in Sweden in this case. So the proxy server forwards our request to websites and works as an intermediary between us and the website in this case. The proxy can be useful if we want to inspect or filter the client traffic, or just hide behind an intermediary. So the server is only communicating with the proxy instead of us directly.